you serious? That's important.
Yeah, it's really weird to like shove stuff like that.
Is it you that?
Oh my god.
It is, but
Alright, so we need to finish off. I want to finish off today's Surds, okay? So get that all done. That means on Thursday, but very questionably, okay, we can move on to start equations, okay? So we get back on track. Right, so finish up some Surds. Right, go on page 14. And we're looking at expanding now. So let's expand from third, starting cube. Right, so we've got root 13, root 2, plus 7. Okay, so using our expanding rule that we learned during the topic of algebra. We all should know how to do it. We also looked at some third laws yesterday and how we put them together. So, root 13 times root 2, so we can put them all under the same symbol. So 13 times 2 is 26. So put them all under the third symbol. Plus number times the third, treat like algebra, that times that, 7 root 13. Okay? So treat it like your algebra. Same sort of rules apply. Root 5 plus root 3. Root 2 take away. Root 2 take away root 7. Okay, so we have binomial product. Two terms, we've got each bracket, so we use our FOIL technique here to expand it. So we use FOIL, F-O-I-L, the X is there, root 5 times root 2, root 10, one and the same symbol. Over outer, root 5 times negative root 7, and negative root 35. For inside, these two terms here, inside the bracket, is root 3 times root 2, both positive, so it's positive root 6. And then alpha last, root 3 times negative root 7, negative root 1. You can't think quite into those. No perfect square number in there to multiply. So we leave it like this. Okay, can't do any more with that. Right, 2 root 5 plus 3. Root 5 take away root 2. Same sort of thing. The only difference now is we have the number at the front of the surd. So we're going to treat it like your 2x. Okay, we also know it's got root 5, so we use our third law there. And we'll get through each term. So again, we're going to do a FOIL, binomial product. So first, the 2 root 5 times root 5. Okay, so you've got the root 5 times root 5, which is 5, root 5 all squared, and then times 2. So 5 times 2, so the first term will be 10. Root 5 times negative root 2, take away 2 root 10, so that 2 stays out the front, and everything inside third will stay inside the third until further simplification is needed. Inner, the 3 times root 5, 3 root 5, we don't show that multiplication between numbers out the front in letters. And then 3 times root 2. Take away 3 root 2. And we cannot simplify that. we're doing a bit of revision, ready for your assessment tomorrow, take a bit of expanding. Okay, so we lock our algebra. We are actually going to work to get ready for the assessment. Can't go any further without picking one. Okay, because there's no numbers multiplied, give me a square number times another number. Give me what we provided the surds, so I can't do any more of that right now. Right, P. So group 6 plus group 2. Group 6 take away. 2. So again, we've got another binomial product. However, if you know your work, you can actually simplify. I do less work in getting your answer. Okay, so you can do it like the FOIL, had 4 terms, but you have something to simplify, or you recognise if the form x plus y, x minus y. Okay, same terms inside the bracket, if the one is fine. Alright, so when we expand, it will be x squared, take away y squared. Same sort of thing here. Okay, x is root 6, x squared, so root 64 squared. Take away y, which is root 2, and we square that. Right, so the square and the root cancels. Okay, we put that in index form, we have half times 2 is 1. And again, the same thing here. 6 take away 2. And this will simplify down to number 12. Questions? Okay, the other good thing about if you want to access videos, you can actually stop it. You know, too quick. You can actually stop it and you have a look at it again if you wanted. Hear my charming voice again. Right, here. 3 root 2, take away 1. 3 root 2 plus 1. So again, you can do a FOIL, 4 terms, then you simplify, or you recognise it's like my x plus y, x take away y, right? You can then take some shortcuts and go to what you're being in. So, that's what we got. The only difference is the sign between the opposite. So we had 3 root 2 times 3 root 2. Let's deal with the numbers at the front first. You've got 3 times 3. 9. And then you also have root 2 times root 2. Right. So multiply that by 2. Take away 1 times 1, 1. 18, take away 1, don't forget that order of operation, multiplication and division done first before any additional subtraction. That's 7 go work there. And always simplify down to push forward. And last one in this set. Okay, so you've gotten the rule, okay, how to extend a square. We can write it as following. So root 7 take away 4, root 7 take away 4, and you can use your FOIL and expand there, okay? It'll take you a bit longer, but you've got another way you can do it if you don't remember how to do it. Alright, but of course we should know how to do expand a perfect square. So first term all squared, so it's root 7 all squared, root 7 times root 7, 7. You then multiply the two terms together and double it. You get 4 times root 7, negative 4 times root 7, sorry, negative 4 root 7, and then you've got to double it after that. Okay, so after that, 8 root 7. So we've got angles, we've done algebra, just looking at the third. Right, the last term is always positive, then we have 4 squared. And then simplify. 7 plus 15, 3, 1, 8, 7. Right, to make sure you're showing all the work you need to show to get these through. Okay, if you want to show less working or more working, whatever your ability is, that's what you need to do to show me that you understand how to do the question. Is there any questions on the project? Okay. Right. Do people had enough, or they wanted to do their homework, or they're happy for me to keep going? One more thing I need to do. Happy for me to keep going?
Yeah.
Okay, so I think we need to do something new.
Oh, yeah, that's fine.
Alright, so we've now got what's called rationalising the denominator. It's now on page 15. Notes. The question's asking you to rationalise, okay? A third is an example of an irrational number, okay, where we cannot write it into a fraction form A over B, where A and B are integers, B is not equal to 0. So what we got is called the process of rationalising the denominator. We then make the denominator of the fraction rational, okay? So in order to do that, I'm going to multiply by root 5 over root 5. Effectively, I'm multiplying by 1, just changing the values on top and bottom to be not 1, but the fraction simplifies down to 1. So when I multiply through, on the top, 1 times root 5, and then root 5 times root 5 on the bottom. Okay? Root 5 times root 5, same as root 5 all squared, so it's equal to 5. What we've achieved is we've made the denominator rational, okay? So it's a rational number, 5. Questions will ask you to do that, okay? That's sort of pretty much what you need to do. Right, again, this is an example of an irrational denominator. The question asks you to rationalise the denominator. It means we need to make the denominator into a rational number. Achieve that by multiplying both top and bottom by that denominator value. Root 7 over root 7. Okay, so let's simplify that down. That'll be 1, so we're effectively multiplying by 1. I'm just changing the values around so that our denominator becomes rational. So 3 times root 7, 3 root 7. On top, and then on the bottom, root 7 times root 7. 7. Okay? So the denominator is now rational value integer. y. 2 over 6 take away root 3. So we've got more things happening on the bottom. We've got some techniques now to tidy this up. Right, before I put something there, does anyone have any ideas on what I'm going to multiply by? Root 3 over root 3. What you'll have then is root 3 times 6, which is 6 root 3, so that won't help.
36.
Something we've already done in algebra and we've already done today.
No, there's still right more. I don't know.
Yeah. Okay. What I've achieved there is I've achieved whole numbers, okay, by doing the difference of 2 squared, this is a technique, and I'll get an integer of that. That's what I'm going to do here. Okay, so to multiply by what's called the conjugate, so it'll be 6 plus root 3 over 6 plus root 3. Okay, conjugate, you change the sign in the middle, so that you can do a difference of 2 squared. First term squared, take away the second term squared, and you will get a rational number. Right, I'm not going to multiply the numerator just yet. I'll show you why in a moment. So it'll be 2 outside of 6 plus root 3. So that times that, I'll just express it into a bracket for the time being. So this is your x take away y, x plus y. Okay, so it'll be x squared take away y squared. So 6 squared, which is 36, take away root 3 or squared. So when we do that subtraction of integers, we're going to get an integer back as well. So the denominator becomes 33. So 2 and 33 don't have any more common factors. That is why I've left 2 out the front, because you can then simplify before you expand. But this particular question we cannot simplify. So we're going to expand out. 2 times 6, 12. 2 times positive root 3. Okay, what I've done is I made the denominator rational. The numerator will still be rational in most cases, but we are rationalising the denominator. Just like we don't put a minus sign on the denominator, okay, we don't always show a rational number in there. Right, root 5 plus root 7 on root 3, take away root 2. Stepping up a bit. Right, so if I do this squared, take away this squared, by setting up the difference of 2 squared by multiplying by the conjugate, that will allow that denominator to be an integer. Now if someone did say, what if you square the whole thing? That's okay, we'll get that all squared, but you've got to think about that middle term, 2 times that, which should still be a third, and therefore the denominator should still be irrational. Okay, so we can't just square it. That, so whatever's on the bottom, you multiply by what's called conjugate, so you change the sign in the middle. So root 3 plus root 2 on root 3 plus root 2. Effectively, I'm multiplying by 1, I'm just changing what that 1 looks like. 7 root 3 plus root 2. So I'm doing that times that, setting it up as a binomial product. Then on the bottom it's different to 2 squared. So root 3, take away root 2, root 3 plus root 2. Very different to take the sign in the middle. Okay, so then I can square those terms between them. So root 3 all squared, root 3, take away root 2 all squared, 2. So take away 2, 1, 7. Can't cancel with anything, so I'm going to be root 5 times root 3. Root 5 times root 2. Root 7 times root 3. Then root 7 times root 2. All positive. We'll have 1, so I'm not going to show that one. Okay. Is everyone having, can you?
Yes.
Yes.
How?
No, they're not tons. Hey.
But at this point, factorising is not really going to help you do anything more. Okay, so if you're leaving it like that, that's fine. The only real point of factorising is when you can cancel with the denominator of a fraction, for example. Okay, but if you leave it like that, that'll be fine. If it tells you to factorise, you need to factorise. Right, one more. I'm done. Right, double A. So, 27th example of doing thirds. One more. Now, there are some issues with showing questions, so let's have a look. Show that 5 on root 2 take away 1. Plus 1 on 7 take away 5 root 2 is rational. So at the moment they're irrational because of the values in the denominator. So we need to use this technique and simplify right through. Hopefully we get integer over integer, no more surds. What we're aiming for. Right, so what was the first thing you would do to show that this is rational? What would you do?
Is this like way back?
We have an addition of fraction. What do we do when we add fraction?
No change, this is the same thing. Yes.
I just said that. You just said that. I'm pretty sure it means
I'm just getting this. Next time we run a lot.
Okay, so you multiply the two values on the bottom together, and then you're going to bring these two, you're going to bring it up to those respective numerators on both sides. Okay, so I've done that times that on the bottom, set it up as binomial product. Right, so that's done, I then can do this. With the numerators, I bring those opposite denominators back up to the numerator. So this 5 is going to get multiplied by that. Okay, so we're just looking at that fraction. I can cancel this with this. Okay, 7 take away 5 root 2 on top and bottom. If I cancel those, I'm back to my original fraction here. Okay, so that's how I can do it. Plus 1 times root 2 take away 1. Now, don't need to put a bracket there because I am adding. Okay, means all those signs stay the same. If I was doing a takeaway, that would mean I need to put those two terms inside brackets. Right, let's expand the numerator out. 5 times that, and then simplify up the top.
Cancel that.
Okay.
Cancel that.
Eventually, when you can set it up, then you can cancel. Right, so 5 times 7, 35. 5 times negative 5 root 2. So multiply the whole numbers at the front, then multiply the surds. Plus root 2, take away 1. And then we've got the binomial product on the bottom. So first, that times that. 7 root 2. Then we do the outer. So root 2 times negative 5 root 2. So we've got root 2 times root 2. Root 2, sorry. Times 5. So 2 times 5 is 10.
Yeah, no, I understand.
You're doing it wrong. Yeah. That's wrong.
Say twice as fast.
Inner, take away 7. 1, negative 1 times negative 5 root 2. 5 root 2.
Oh, that's one thing.
Okay, so you've expanded the top and the bottom. Simplify. 35, take away 1. Negative 25 root 2 plus root 2. So it's the same as negative 25x plus x. Negative 24x, which is 24 root 2. So negative 10, negative 7, negative 17. However, I'm going to leave the positive term. So 7 root 2 plus 5 root 2. 7x plus 5x. 12x. Which is 12 root 2. Take away negative 10, take away 7. Negative 17.
How do I know?
That's wrong.
Right, so we still have a irrational number because of the root 2 on top and bottom. So now let's multiply by the conjugate. Okay, so you grab the denominator of your irrational denominator, multiply top and bottom by the conjugate. Hopefully what this will achieve is taking all those surds out. So I'm setting up the numerators to do a multiplication of binomial terms.
Yeah, it's easy, bro.
And then I can multiply the denominators by the difference of two squares. So 12 root 2 times 12 root 2. So root 2 times root 2 is 2. This beyond people's head now?
Yes.
Okay.
48.
If you can do this maths, you're doing well, okay?
Do this.
Be involved in this question, okay?
Do this. 144. So it's 288.
Yeah, that's what I got.
88.
Minus. I'm not something.
17 squared.
I can't.
Yeah, I got that wrong.
289.
Thanks, Mr. Calculator.
Well, this is looking promising.
Oh no.
Bottom.
It's going to be a negative one.
Yeah.
Oh, wait.
However, you need to show the whole thing, okay? So we've still got thirds on top. So we need to pick them up first. Right, so we need to do a boil up top. That times that.
Oh.
Oh, we're not done yet.
What's 34 times?
34 times 12.
That is. You do a constant.
It's like three. It's something. It's 400.
408. Yeah, that is 408.
Yes.
Yes. 10 times 34 is 340, and 2 times 34 is 68.
Really good.
Oh, it's fine. That's 4. See that? See what happens when you sense those grades?
408.
It's not important.
Root 2.
Yes, examination.
And then 17.
Tina, outer. 34 times 17. We'll do later on that. Negative 34 plus 17. I just want to show that it's rational. That means I need to show everything's an integer. I'm really concerned about thirds at the moment. Okay, inner 24 root 2 times 12 root 2, so root 2 times root 2 is 2. 12 times 2 is 24, so what's 24 squared? I feel like I've got one question too far. 24 squared.
480 something. I don't know. That's 480. That's off the top of my head.
No,
No.
480.
What is square?
576. 576? How?
Well, first by first, 4 times 4 is 16.
Yeah.
Oh, you went correct.
And then that's how.
Now last term, so 24 root 2 times 17, I'm hopeful that's 408. So 24 times 17. 4 sevens are 28, so 7 plus 7. 24 times 17. 408.
408.
Take away 408 root 2. Look at that. 408 root 2. Take away 408 root 2.
That's beautiful.
Shit.
And we go.
Over. Negative 1.
Oh, it's over -1. Okay. Then we have a.
Then they all cancel out. The surds cancel out, so it's all nice.
It's supposed to be 578.
Wait.
Okay, hear what he said. The thirds cancel out. That is all that matters. Everything else is an integer. Okay? Rational means we can express it as a fraction where the numerator and the denominator are both integer value. So,
Sure doesn't know what to do.
I don't think you pressed it hard. You didn't, right?
Just say you know what to do.
Oh.
okay, so equals. So again, this will cancel 408, take away 408. Okay, right. So equals negative 34 lots of 17. I don't really care what that is, we don't need to evaluate that. Take away 576 over negative 1. All I'm concerned is that the numerator and the denominator are both going to be integer values. Okay, so which is rational 6 both numerator and denominator are rational. Or integer value. Okay? So once we've shown that they're both top and bottom are integers, we can stop. So this sort of question, you can't just go to your calculator, back to your original question and show that a fraction where integers, you have to show it, therefore you actually need to go through that working and show and justify it.
Oh. Oh. I didn't save and the game cards popped out. Like 3 times.
Alright, so that's now up to 2.23. So, do not start this tonight, okay? You're focused on the algebra. Alright, making sure you're ready for that and your basic arithmetic ready for tomorrow. That will mean
578, by the way.
Yeah.
34 and 17. 578. Negative. Yeah.
more.
So it's like
So it's 2. So the whole thing is 2 over negative. No.
No, it's a
It's
negative.
negative. It's like negative 1,000.